So now in this video we want to continue from the previous video when we started doing the simulation of our inverter. So we would like to lay the inverter out now. So we need to have a layout cell. Get into cells here, new cell, and we're going to have a layout, and we want to call it inverter. You want to call it the same name as the schematic because we're going to do a layout versus schematic check to see that both match, so they would need to have the same name. So press OK in that. So that's us got access to now a layout here. So if we get into the components, these components are going to be available to us. Now we know that the inverter is going to have an NMOS device at the bottom, so there's an NMOS device, and it's going to have the PMOS device at the top. So we click on the PMOS, that's the PMOS here. So I'll just move these down a bit. Now the size of the PMOS was 20, so we can double click on this and you've just got the width here. You can see it's there, it's 20, and the size of this one is 10. Now what we'll do is we'll turn them round on their side and we'll draw it with them on their side. So what you can do is you just select this and we can Control J, we'll turn it 90 degrees, and this one here, Control J, we'll turn it 90 degrees. Now in order to work with this PMOS device, we need to get the access to the active region. So we're going to create in effect what would be the contact through to our source and our drain. So we've seen this whenever we developed the a PMOS and NMOS transistor in a previous video. So we need the access to this active layer. So it's this P active. So we're going to get P active here, and it has to be the same size as this. So we'll make it the 20. And again, we can turn this round, Control J. I'll just take it over here so we can see it, that's it there. And we'll do the same again. We're going to have a P active. And it's going to have size 20. And we'll do Control J. Now what we'll do here is we'll just select all of them. In fact, before we do that, we'll connect the actual active regions together. So if we left click here and right click here, you'll see we've got the green going all the way through. So this active region is connected, and we've got left and then right, and we'll move everything up a bit, make it neat and tidy. Okay, so that looks okay. And now we can select all of these here, and we can get into the, let's see, it's the tools window. Let's see, tools here, network routing, or is it window, fill display, measurement. We want to squeeze these together. Find out where it is. ERC, network log, place, routing, generation, compaction. There it is, compaction. Found it. So click on the compaction. So that's going to compact that together. So this is our NMOS device. Edit, undo it. Okay, that's our NMOS device. And we can move it to wherever we want it. Now we do the same for our PMOS device. We'll, with our sorry, if that's our PMOS device, we'll do the same with our NMOS device. So our NMOS device, we need access to the active region. So we're going to use the N active, and then again an N active here, and we'll change the sizes of these. So that's going to be 10. And this one here is going to be 10. And we'll turn this round, Control J, and we'll turn this one round, Control J. And we'll just position this the right height. And this one as well. And we'll connect the active regions, left click, right click, left click, right click. And now we can grab all of this and we can go Tools, Compaction, do Compaction. And this has got our NMOS device. and we can shift that along. Now, in order to prevent any errors, we have to make sure that the wells here are butted up against one another. So we'll have to shift this just until the well touches. So that's it, just touching there. If we left that with a gap, it would come up with an error. Now, as we said in a previous video, the PMOS device exists in an N well. So this is the N well here. And an NMOS device, which is here, exists in a P well. Now the N well here has to get connected up to our VDD, and our P well here has to get connected to our ground. So we'll connect that up just now, and then I'll show you why that is. So first of all, we need to get access here to the N well. So here's an N well here. So it's a PMOS device sitting in an N well. So we'll grab this one here and we'll stick it up here. I'll zoom out a little bit so we can see it. Okay, that's better. Now I'll move it up a wee bit, and again we're wanting to connect this, and we'll make it, again we'll make it 20. Apply OK. So that's that one there. And again, we need to butt the wells together. So maybe it's awkward to see this. I'll zoom in a little bit so that you can see it here. Okay, so you can see here we've got the N well and the N well here. So we want to make sure the N wells are touching. So we'll just grab this and shift it down just to the N wells touch. And that's N wells touching here. So don't worry too much at the moment if you're going to have a little bit hanging over at the edge there. That's just because the size, the movement I have here set up within the screen, so it doesn't matter. That N well is sitting butted against that N well just as we require. Now in the bottom here we said we've got an NMOS device, so it's going to be a P well, so we're going to have access here to the P well, and that's going to be going to ground. And again we'll make this P well 20. Okay, so again we need to connect this one, so make sure that this well here connects to that well. So we just shift it up and you'll see at that point there it's now connected. So now that we've got most of the stuff we require for the devices, we'll actually start connecting them together. So this is going to be our VDD. So our VDD in effect connects to the N well here, and it also comes into this transistor. So this is a PMOS transistor, so the source is holes which come from the positive side. So we're going to go, this would be the source here, and we'll make this the drain. So we're going to come in here, so if we come in here and we left click and right click, you'll see that we've got a metal 1 connection. So that's our VDD coming down onto the source of this PMOS. And then we're going to connect the drain of this to the drain of this one here. So again, left click and right click, and that's the drain connected to the drain. And then we're going to have the source of this one here connected to ground. So we go to the source here, left click and right click, and that's that connected to ground. And finally we're going to connect together the polysilicon gate. So the gates connect together, we left click and we right click, and that's ostensibly the design done for the layout done for our inverter. There's only a couple of things we need to add in, and those are the contacts and the output. So here's the output here. So it's where the two drains come together. We left click and we can right click, and that's the output here. And we also have to connect an input into the gate. It's the polysilicon gate. So here is the connection here. You can see that's the metal 1 to polysilicon 1 contact. So we can put that down here, and it means we can left click here and right click here, and we've got the connection here to our input. So now what we want to do is name these so we can get access to them during the simulation. So if you click the one at the top here, and we can go export create export, and we'll call that one VDD, and we'll click on that one, export, create export, and we'll call that in. Click on this and we'll go export, create export, we'll call that out. And finally we'll have the bottom one here, we can go export, create export, and we'll call that ground, GND. Now we'll just make these a little bit bigger so that you can see them, so you can get access to this. So I've got a little cross here, select that one, select that one. So select that, sorry, and we can shift and we'll select that one and keep your finger in the shift so that you're selecting each of them. So finger, that's it, and shift. So we've got access to all of these, 4 of these. So if I do the Control I, you'll see here we can change the size of these 4 at the same time. So we make the size of this 5 just to make the light writing bigger, and we can see them here. So now we've got our layout complete here. Let's have a look at it in our 3D. So if we go to Windows and 3D view, and this is our 3D view here. So let's get this into some sort of, oh, there we go, that looks decent. So we've got the gate, so that's the gate over here, and you can see that the gate here runs across here, and it's the gate controls the current that's flowing. So the current's going to flow along the length of the transistor. So this is the width of the transistor here, and this is the length of the transistor. So in effect the channels that are become inverted or depleted as the channel here. Okay, so that's our channel here, and this is in effect our active region from here to here for this transistor, and the active region from here to here for this transistor. And this is the PMOS device. You can tell it's a PMOS device simply in this case here because it's bigger. It was a width of 20, and this one, the NMOS, was width of 10. So that's our input here. We've got our in through metal 1 and down through onto the polysilicon gate, and this is the gate here. So it's the voltage in the gate that controls the current that flows across this device and also across this device here. And we're going to have the VDD, which is up here. Okay, and the VDD is connected down onto the well here as well. Okay, so the well is connected onto the VDD. So this is the PMOS device sitting in an N well. So the N well is connected to VDD, and also we've got the source connected to the VDD here as well, and we've got the 2 drains connected from each of the devices, and this is the output. And then we've got finally at the bottom here, we've got the source of this NMOS device, which goes to the ground, and again the ground is connected to the well here, and it's an NMOS device, so this is a P well, and this is connected to the ground is connected to the P well. So if you like, you could see that if we looked at from the top to bottom, the current would flow down through here, which is our metal 1, onto our drain, and then if I can try and get this right proper, then it would flow across the active region here, being controlled by the gate, and this would be our output here, and we'd also have the current flowing down, and we would have the current flowing across this device here, which is our NMOS device, and it would be current controlled. The current flowing through here would be controlled by this gate polysilicon layer, and finally it would go into the source and out through the ground. So we've got our ground, VCC, we've got our input, and we've got our output, and that's our little inverter. So that's enough of the 3D. Let's continue and we'll work through and we'll create a schematic for this, and we'll do the test on this as well to see whether it actually works. So before we can do any simulations, we have to check and see whether this actually breaks any of the design rules for the layout. To do that, we can go into Tools, DRC, and you can check Hierarchy. So you can see at the bottom here, there is no current cell for this operation, so it doesn't know what it's doing. So we have to go and select it, and then we can do Tools, DRC, check Hierarchy. And it says here that the DRC found 1 error and 0 warnings. So let's have a wee look and we'll see what the errors are and see if we can fix them. So if you head up here, you can see in the Explorer section it's got the errors, and this is the inverter error here. Now as you work through and do more and more designs, you get used to all the rules for layout as you get to know your process. But in this case here, there's some issue here. Now I'm not going to go through all the details because it's beyond the scope of the course, but as you work through and design more cells and more blocks, these errors become apparent and you'll know right away how to fix them. So for instance, in this case here, I know I've created this device using compactions, which has compacted it together, and sometimes you get an error here because it prefers if you were to give it a little bit more space. So if I pop that out by 1, and if I run through again, and I'll do this one here to keep it the same at both sides, then if I run through again, DRC, and check this, and you can see now there's 0 errors and 0 warnings. So I won't get into the details here, but as you work through, you get used to it, and you'll get to know how to deal with the errors, and there's lots of common errors that occur and you can fix them quite quickly. So this is our schematic. Here we've checked the DRC, so the design rule check, it's fine. So what we want to check here is check the wells and see the wells are connected properly. So for I connect on that, it says no well errors were found, so all the wells are connected. That is the N well and the P well are connected together and they're butted up against one another. Now there's another one we can check here, is in effect it's the layout versus schematic, which is this one here. It's called NCC. So that's schematic and layout view, cells and current window. So if you click on that one there, and you can see here that NC command completed 0.15. So there's comparing inverse, blah, 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 errors. So there's no errors here. All the sizes match, topologies match, and exports match. So this is A-OK, and this is good to go. Now again, we want to associate these with our SPICE model. So if we click on this one here, and we can get into Tools, Simulation SPICE, and we can set SPICE model, and we can get access to this. I think we can just control, that's us got it there, and we can do Control I, and this is going to be our CMOS P, and we'll make it a size, let's say 3. Okay, so that's a CMOS P, and this one here, we click on this device here, and we'll go to Tools, SPICE, Set SPICE Model, and we select it, Control I, see again, cancel, see if we can select it properly. That's it selected now, Control I, and this is going to be our CMOS N, and again we'll make it 3 so we can see it. Okay, so we've associated our SPICE models here, so let's go ahead and we'll create a schematic, we'll create a test window for this. So to run through the simulation for this layout here, we'll create a new cell. So go into Cell, New Cell, and make sure you're in layout, and we'll call it inverter underscore sim. So this is simulating the layout. Press OK in that, and you'll see that we've got this sitting here. Now what you can do is you can go up to this inverter layout and you can just drag this across into here, and you can click on this here to the pin, and you can left click, right click, and it will draw a metal 1, left click, right click, left click, right click, and left click and right click. Now what we'll do is we'll export these again. So if you click on the pin, so there's the pin there, you click on that pin there and you go to export, create export, and this is our VDD, and we can click on this one and export, create export, and this is going to be our in. Click on this one, export, create export, and this is going to be out, and we can click on this one here and export, create export, and this is going to be our ground GND. Okay, so now what we can do is you can actually look down inside this hierarchy. So if you click on this, you can click that there, and you can see actually down inside this hierarchy here, and you can, okay. So finally we have to grab the spice code and copy it from the schematic into the layout. So if you click on the schematic, you see we've got our spice code here. So what you can do is just select it here, go Control C, and we'll paste it into the layout. So we can come in here and go Control V, and we'll make it a little bit bigger. So Control I, and we'll change that. We'll pop it up to a 2. Apply. Okay, so that's us got our spice code sitting there, ready to run the simulation. So finally we can go up in here and we can go to Tools, Simulation Spice, and we can write Spice Deck. So, and that's us written the spice code. That's it, that's simulated. Now we can click on the window up here, and we can click on V in and V out, and you can see it's run through this simulation. So now instead of running through the simulation via the schematic, we'll run through the simulation, and it's extracted all of the parameters we require from the layout. So this is in effect the test to see if the actual layout is going to work. And you can see that we've got our input here changing from a low voltage to a high voltage. That's the blue one here, and we've got our output here changing from a high voltage to a low voltage. So this is doing the inversion, and you can see here that we've got small fluctuations here, so that little ringing at the edges here, but we don't need to get into any of the detail on this. We just want to make sure we get this up and working, and we can run through a simulation and get the correct outputs. So that's all there is for this video. We've come through quite a lot in the last 2 videos, and we'll be able to use what we've learned in order to go ahead and simulate and also lay out some other circuits which we've already looked at. So thank you for listening. I'll get you in the next video. Goodbye.